हाय फ्रेंड्स, इस वीडियो में हम हाउ टू फाइंड द इनवर्स ऑफ द मैट्रिक्स बाय यूजिंग गॉस जॉर्डन मेथड ये सीखेंगे। तो एक टेक्निक होती है, दिस इज द वन मेथड टू फाइंड द इनवर्स ऑफ द मैट्रिक्स। सो हियर दे राइट a is same as I times a और some author write a is a augmented matrix I। तो ये कैसे कन्वर्ट करते हैं? इस ए मैट्रिक्स को आइडेंटिटी मैट्रिक्स में कन्वर्ट करना है, और जो आई मैट्रिक्स, जब ये मैट्रिक्स ए आइडेंटिटी में कन्वर्ट होगा उस समय यहाँ पे जो भी मैट्रिक्स मिलता है, ये जो मिलने वाला जो मैट्रिक्स होता है ये हमारे मैट्रिक्स का इनवर्स होता है। मैं यहाँ पे एक स्टेप बाय स्टेप एक्सप्लेन करूंगा। मुझे फॉर एग्जांपल दिस इज माय फर्स्ट स्टेप, हियर आई एम अप्लाइंग एलिमेंट्री रो ऑपरेशन ऑन ए। हियर आई एम अप्लाइंग एलिमेंट्री रो ऑपरेशन ऑन ए। For example, here I get the matrix A1 here in right side, and let's say this is, here I am writing this I1. Let's say in the starting this is the identity matrix. So after applying elementary operation, let's say here I am taking I1. अगर इस स्टेप में, हमारे फर्स्ट स्टेप में, ये अगर A1 आइडेंटिटी मैट्रिक्स में कन्वर्ट हो गया पहले ही एलिमेंट्री ऑपरेशन में, तो उस समय जो ये हमारा I1 रहेगा यही हमारे मैट्रिक्स का इनवर्स होगा। अगर ये A1 आइडेंटिटी मैट्रिक्स में कन्वर्ट हो गया, if A1 is I, then this I1 is the inverse of my matrix. If not, here if not, अगर A1 मेरा आइडेंटिटी मैट्रिक्स में कन्वर्ट नहीं हुआ तो मुझे क्या करना पड़ेगा? और एलिमेंट्री ऑपरेशन और एक एलिमेंट्री रो ऑपरेशन इस A1 वाले मैट्रिक्स को लगाना पड़ेगा, और एक मैं एलिमेंट्री रो ऑपरेशन इस A1 वाले मैट्रिक्स पे लगाऊंगा। फॉर एग्जांपल, आफ्टर अप्लाइंग दिस एलिमेंट्री रो ऑपरेशन ऑन दिस A1, लेट्स से दिस A1 इज कन्वर्टेड इनटू A2 एंड दिस I इज कन्वर्टेड इनटू लेट्स से I2। अगर दिस स्टेप में, अगर if A2 इज माय आइडेंटिटी मैट्रिक्स, अगर A2 मेरा आइडेंटिटी मैट्रिक्स में कन्वर्ट हो गया तो उस समय हम ये जो I2 जो यहाँ पे जो मैट्रिक्स मिल रहा है कोई भी, ये मेरा इनवर्स हो जाएगा अगर मिल रहा है तो। अगर इफ नॉट, अगेन आई हैव टू अप्लाई एलिमेंट्री रो ऑपरेशंस until and unless, here let's say until and unless this matrix is converted into identity matrix, and let's say this is, here I am writing in. So this, let's say here this is not in, so here I will write this in as, let's say this is the B. So until here first I am applying elementary row operation, and this A is converted into A1. If A1 is the identity matrix, this I1 is the inverse of my matrix A. If not, again I will apply elementary row operation. If this A2 is the identity matrix, then this is my inverse. If not, again I will apply elementary operation until and unless this right side matrix, that is this matrix becomes identity, and whatever the matrix here I get, this matrix is the inverse of my A matrix. That is the rule. Here I will use this rule and I will solve this problem. You will get a complete idea. Here this is the matrix of order 3x3. ये हमारा 3x3 मैट्रिक्स है। इस मैट्रिक्स का मैं इनवर्स फाइंड करके बताऊंगा यूजिंग गॉस जॉर्डन मेथड। So here I will write this matrix as here A augmented matrix I। Here यहाँ पे ये मेरा 3x3 मैट्रिक्स है, तो ये जो आइडेंटिटी मैट्रिक्स होगा मेरा, ये भी 3x3 मैट्रिक्स होगा। तो यहाँ पे मैं अभी फिर एक स्टेप लिखूंगा here, और एक मैट्रिक्स लिखूंगा, यही मैट्रिक्स लिखूंगा 8 4 3 2 1 1 1 2 1। तो यहाँ पे क्या रहेगा? ये आइडेंटिटी मैट्रिक्स, ये मेरा 3x3 मैट्रिक्स है A, तो यहाँ पे मैं आइडेंटिटी मैट्रिक्स ऑफ ऑर्डर 3x3 ही लूंगा। अगर ये मेरा ये 4x4 होता तो यहाँ पे मैं आइडेंटिटी मैट्रिक्स ऑफ ऑर्डर 4x4 ही लेता। तो यहाँ पे दिस इज आइडेंटिटी मैट्रिक्स ऑफ ऑर्डर, सो 3x3 1 0 0 here 0 1 0 0 0 1। तो अभी मेरा फर्स्ट स्टेप क्या रहेगा? इस मैट्रिक्स को मुझे आइडेंटिटी मैट्रिक्स में कन्वर्ट करना पड़ेगा। कैन आई स्वैप माय रो 1 एंड रो 3? हियर आई एम अप्लाइंग द एलिमेंट्री रो ऑपरेशन एज स्वैपिंग ऑफ रो 1 एंड 3, means here row 1 is swapping into row 3. So in the upcoming matrix, जब मुझे मैट्रिक्स मिलने वाला है इसका मतलब होता है कि जो मुझे अभी मैट्रिक्स मिलने वाला है, इस मैट्रिक्स में रो 1, इस रो 1 को रो 3 की जगह लिखूंगा, इस रो 3 को रो 1 की जगह लिखूंगा, और जो मेरा रो 2 एज इट इज रहेगा। ये स्वैपिंग का मतलब होता है कि जो मेरे आने वाली मैट्रिक्स है, इस मैट्रिक्स में जो रो 1 होगा, इस मैट्रिक्स का रो 3 होगा, और इस मैट्रिक्स का जो रो 3 रहेगा, इस मैट्रिक्स का रो 1 रहेगा। मींस हियर आई एम राइटिंग इन प्लेस ऑफ रो 1 इन दिस मैट्रिक्स, हियर आई विल राइट रो 3 of this matrix, and in place of row 2 here I will write row 2 same as it is, and in place of row 3 of this matrix I will write row 1 of this matrix. That is the meaning of this elementary row operations. Here so this is here. Now tell me the element. Here 1 2 1, here 0 0 1. Here second row as it is 2 1 1, and this second row is also as it is 0 1 1. Now in place of third row, here I am writing first row 8 4 3. Here 1 0 0, this first row. Here now tell me the second elementary row operations. Here I will write the second elementary row operation as I want to convert this 2 and 8 into 0. So जब भी हमारा यहाँ पे 1 मिल गया, तो उसके बाद प्रयास ये कीजिए कि इस 1 के नीचे सेम कॉलम में जितने भी एलिमेंट है, इनको 0 करने का प्रयास कीजिए। अब मैं क्या एलिमेंट्री ऑपरेशन लगा सकता हूँ? R2 चेंजेस टू R2 माइनस 2 टाइम्स R1, ये मेरा पहला एलिमेंट्री ऑपरेशन होगा। एंड R3 इज चेंजेस टू R3 माइनस 8 टाइम्स R1. Then I get the matrix as here. Now tell me the matrix here. 1 first row as it is 1 2 1, second row 2 minus 2 times 1 0, 1 minus 4 that is minus 3, 1 minus 2 this is simply minus 1, 8 minus 8 times 1 this is simply 0, 4 minus 16 that is minus 12, here 3 minus this is 8, this is simply minus 5. Now come to here. Here simply first row as it is 0 0 1, same operation also we have here we have to apply 0 0, here 1 minus 2 times 1, here 1 minus here this is 0, here 0 minus, here 0 minus 2 that is minus 2. Now come to the row R3, 1 minus 8 times 0, here 1 0 0 0, here 0 minus 8 times R1 that is minus 8. Now I want to make this minus 3 as 1. So first I will make this minus 3 as 1. So by applying elementary row operation, here I am multiplying minus 1 by 3 to the row R2. So first I will make this minus 3 as 1. जब भी हम इस एलिमेंट को 1 करने के बाद इस सब एलिमेंट को 0 करेंगे, हमारा सेकंड टारगेट ये रहना चाहिए। इस -3 को मुझे 1 में +1 में कन्वर्ट करेगा। कन्वर्ट करने के बाद पहले मैं कर लेता हूं, ये 1 2 1, ये फर्स्ट रो हियर 0 0 1 एज इट इज। नाउ सेकंड रो 0 हियर -1 by 3 -3 1, हियर दिस इज 1 by 3 एंड ये 0, ये दिस इज -1 by 3 and this is 2 by 3. Third row as it is 0 -12 -5, this is 1 0 and this is -8. Now try to convert this -12 and this 2 as 0. Can I apply here elementary row operation as R3 changes to here R3 plus 12 times R2 -12 plus 12 0. R1 changes to here I want to make this as 1, R1 minus 2 times R2, so 2 minus 2 times 1 this is 0. So here I get the resultant matrix as, here first I will write the element of row R1, 1 minus 2 times R2 that is simply 1, 2 minus 2 times 1 simply 0, 1 minus 2 by 3, here 1 minus 2 by 3 that is simply 1 by 3. Now here 0 minus 0 0, 0 minus here 0 minus minus plus 2 by 3. This is 2 by 3. Here 1 minus, this is 4 by 3. Here 1 minus 4 by 3. That is simply minus 1 by 3. This is simply minus 1 by 3. Here I will take this. Now tell me the second row. Second row is as it is. No, here elementary operations are through R3 and R1. At that time R2 remains same. So this is 0. This is 1. This is 1 by 3. Now tell me the second row. Here second row is as it is 0 minus 1 by 3 and this is 2 by 3. Now tell me the third row. R3 changes to R3 plus 12 times R2. Now this 0 plus 0 minus 12 plus 12 0. This is, now tell me this operation here. This is minus 5 plus 12 by 3. That is 4. That is minus 1. So here 1 plus 12 times 0, simply 1. 0. This is 0 minus 12 by 3. So this is minus 4. Now come to the third operation here. This is minus 8. This is minus 8 plus 24 by 3. So this is 8. That is 0. Now come to here. Now I want to make this 1 by 3 and this 1 by 3 as 0. Here can I apply my elementary operation as row R1 changes to R1 plus 1 by 3 times R3. This 1 by 3 and this minus 1 by 3. This 1 by 3 and this minus 1. So this plus 1 by 3 minus 1 by 3 becomes 0. Here again I am applying here R2 changes to R2 plus 1 by 3 times again R3. So 1 by 3, this minus 1 by 3 becomes 0, this second row. Now here, now tell me my first row. So I will write here. Now tell me my first row. Here 1 plus, this is 1 plus 0, 0, 1, 0 plus 0, 0. This plus 1 by 3, this minus 1 by 3, 0. Now here 0 plus 1 by 3, simply 1 by 3. This is 2 by 3 minus, this is 2 by 3 minus 4 by 3. So this is minus 2 by 3. This is minus 2 by 3. Now tell me here this third element. Now third element is minus 1 by 3. Here minus 1 by 3 plus 0. Simply direct minus 1 by 3. Minus 1 by 3 plus 2 times 1 by 3 times here this is 0 no? That's why this is minus this R3 changes to R2 changes to now tell me this is simply minus 1 by 3. Now tell me the second row element. Here 0 plus 1 by 3 times 0. This is simply 1. This is 1 by 3 minus 1 by 3 0. Now tell me this 0 plus 1 by 3 times. So here 1 by 3. Here minus 1 by 3. And this is minus 4 by 3. This is minus 1 by 3 and this is minus minus 1 by 3. R2 changes to this is minus 1 by 3 plus 1 by 3 times this is minus 4 by 3. That is simply minus 5 by 3. Now tell me here the third, that is simply 2 by 3. Now third row is as it is. So here this is 0, 0, minus 1 and this is 1, minus 4 and this is 0. Now here I want to convert this minus 1 as 1. So can I apply my elementary row operation as minus 1 to the row R3. Then I get the resultant matrix as here. Here I am writing 1, 0, 0. Here 1 by 3 minus 2 by 3. It is minus 1 by 3. Here second row is 0, 1, 0. This is 1 by 3. This is minus 5 by 3 and this is 2 by 3. And here this is 0, 0, 1 and this is now here I am multiplying minus 1. This is minus minus plus 4. Here this is 0. Now here this matrix is converted into identity matrix here left side, and this matrix, let's say here I am giving the name as B. Now this B matrix is the inverse of my original matrix A. So you can check here A inverse into A equal to I. So I will show this also here. This whatever this B matrix is the inverse of my A matrix A. Here I will write this B as B equal to, here B equal to, which is equal to, let's say A inverse, which is equal to here 1 by 3 minus 2 by 3 minus 1 by 3, and here 1 by 3, this is minus 5 by 3, 2 by 3, this is minus 1, this is 4 and 0. So I will show here the A inverse into A is identity or not. So I hope all of you write this. So I will show this matrix, whether this matrix is the inverse of A matrix or not. Here I will calculate. Now here, see here, if this matrix is the inverse of this matrix here. So if this matrix, let's say here B matrix, here I am writing this B as A inverse and A is equal to I. Let's say here I am giving this is B as A inverse. If this matrix is the inverse of this matrix, so the product of this A inverse into A is equal to I. So how? So just see here. Now tell me the A matrix here, A inverse matrix. Here I will show this product is I or not. Here 1 by 3. This is minus 2 by 3. This is minus 1 by 3 here, and this is A. Here I will write here 8, 4, 3. This is 2, 1, 1, 1, 2, 1. Now here this is 1 by 3 minus 5 by 3. This is 2 by 3, and this is minus 1, and this is 4 and 0. If this matrix is the inverse of this matrix, that product of this should be some identity matrix. So I will calculate whether this matrix is the inverse or not. So if this is the inverse, if the adjusted matrix is the inverse, that product should be identity matrix. Now tell me here matrix multiplication is simple. First row, first columns. This is simply 8 by 3. So here minus here, that is 4 by 3, here minus 1 by 3. So here second row, this means first row, first columns. Here 8 by 3, this is minus 2 by 3 into this 2, that is minus 4 by 3. This minus 1 by 3 into this 1, this is simply minus 1 by 3. Now second row, second column is this entry. So first row, second column is this entry. So this is simply 4 by 3 minus 2 by 3, and this is minus 2 by 3. Now here, now first row, third column is this entry. Now this is 3 by 3. Here 1 by 3 into 1 by 3. Here this is minus 2 by 3, minus 2 by 3. This is here minus 2 by 3, and this is minus 1 by 3. Here now second row, first column is this entry, A to 1 entry. So second row, first column is this entry. Now here tell me, this is 8 by 3, 8 by 3 into 1 by 3 into 8, minus 5 by 3 into this. So that is minus 10 by 3, and this 2 by 3 into 1 plus simply 2 by 3. Now second row, second column is this entry. Here 1 by 3, that is 4 by 3, and this is minus 5 by 3, and this is plus 4 by 3. So now come to here, second row, third column is this entry. Here 3 by 3, here minus 5 by 3, and here plus 2 by 3. Now come to here, third row, first column is this entry. This is simply minus 8, this is simply plus 8, and this is 0. Now third row, second column is this entry, minus 4, this is plus 4, and this is this is 0. Now third column is this entry, this is -3, this is 4 into 1 plus 4, and this is 0 into 1 plus 0. Now here see, this matrix is, this is here 8 by 3 and this is minus 5 by 3. So 8 by 3 minus 5 by 3, 3 by 3, this is 1. This is 4 by 3 and plus 4 by 3, this is minus 4 by 3, this is 0. This is 3 by 3, that is simply 1, and this is 3 by 3, simply 1. So here 1 minus 1, 0. Now come to here, this is 8 by 3, this is plus 8 by 3, this plus 8 by 3, 10 by 3, this minus 10 by 3, 0. Now come to here, this plus 4 by 3, this plus 4 by 3, means 8 by 3 minus 5 by 3, that is 3 by 3 becomes 1, you can calculate. Here this is, here we can check, this is 0, here 3 by 3 is 1, and this is minus, and this is 2 by 3, this is 3 by 3 is 1, and this is minus 5 by 3, you can check this as 0. Here minus 8 plus 8, 0, and this is plus 4 minus 4, 0. Now you can check this minus 3 plus 4, here it becomes 1. Now here this matrix A inverse, now here this B, whatever B which is I have denoted as A inverse, this matrix is the inverse of this matrix. Why? The product of these two matrices, let's say this is B, or we can say A inverse into A is equal to I. So this matrix is the inverse, we can find by here, we find by using the Gauss-Jordan method. Thank you.